So this question, we're looking to find the distance, right? Distance between those 2 points. I think the safest thing, and if you do this, awesome. If not, then just make sure you're being cautious. But I always like to stack my points, 4, 8, and -44, -6. I think I talked about this the other day. I'll go 4 minus -44, but then I'll accidentally go 8 minus 44 as well, or something like that. And you know that y's can't be paired with x's. You can't do algebra with those things. If I stack them, I know then that I'm only going to be dealing with the x's with x's and y's with y's. Okay. If you remember your formula from yesterday, I'll write the whole thing up here, but it is something we need to remember for tomorrow. We subtract our x's, square that quantity, and subtract our y's and square that quantity. But you can do it in any order. It doesn't matter whether you go 4 minus -44 or 44 minus 4. -44 minus 4. It doesn't matter the order. You'll still get the same result that we're looking for because of that power of 2. So when I do this, I'm going to subtract my x's. So 4 minus -44. So 4 minus -44 gives me what? 48. Okay, so minus and negative becomes addition. So you got 48, and we're going to square that. It's going to be a pretty large number, so we'll grab our calculator here in a moment to evaluate that for us. And then we're going to go 8 minus -6. 8 minus -6 is 14. That one is not too bad. Does anybody know 14 squared, what that is off the top of your head? 196. Okay. As we go through the year, we're going to do a lot of radical work. So it does become maybe a necessity. It'd be very useful if you guys learn your perfect squares, like up to 20. Okay. Most of you probably already know them up to 100 at least. Would be 10 squared. But going a little bit further would be very useful. But 48 squared, that one is 2304. We're going to add that to 196. So we get here underneath the radical is 2500. Okay? Which ends up being a perfect square. Okay? So I think this question, because of the way it asks us to type an exact answer, it does say using radicals is needed. So we'll do another one here and see if it does provide a radical. Did anybody do this and get a radical? You should be able to do this, I would think, every question. This will simplify down to, in this case, 50. Okay. Remember, this is a symbol. Let's see here. This here, the radical, okay? First thing, let's talk about that radical real quick. That symbol kind of looks like that, doesn't it? Like a lowercase r. All right, so that's why we have that. It's kind of supposed to be a lowercase r. But the radical of 2500, that's a symbol for the number that I multiply by itself 2 times to get 2500, okay? So every time you see a radical, it's actually representing another number, okay? And in this case, it's 50, okay? Multiply 50 by itself 2 times, 50 times 50 gives me 2500, okay? Now, from last year, this always becomes something that people kind of neglect a little bit from previous years because it was hard. But you don't realize at that point, maybe last year you didn't realize how much you're going to need it this year. But if I wanted to take 2500 and I didn't have a calculator, because there will be a point this year where I take your calculators away from you and say you can't use them on tests and quizzes, and I want you to be able to do this radical work by hand because of how much you're going to use it next year and the following year and the following year. And it just benefits you to be able to do things by hand. We're going to try to factor this thing. Okay, find 2 numbers that multiply together to give me 2500. Well, looks like 100 is going to go in there, right? Okay, so I'm going to put 100 in there. And if 100 divided through this number will give me 25. So I just found the factor of those two things. Okay. Now I'm going to go to 100 and find the factors for 100. And there's a lot of different factors. There's 2 and 50. There's 10 and 10, whatever you want to use. Okay, 25 and 4. Regardless of what you choose, I'll just use 25 and 4. And then we'll do the same thing with 25. But regardless of what you choose, if you've got options, you will always eventually get down to the same answer that somebody else would have gotten. They used a different number, okay, or different factors. I get down, when I did this 25, I got down to 5 and 5. Those are what kind of number? What kind of number is 5? If it's only divisible by itself and 1. It's prime, okay? So we stop at prime numbers, okay? So I'm going to stop right there, and I'm going to stop right there at this one, okay? But 25 over here can still go further. We can still find factors of 25. So I'm going to break that down a little bit further. To 5 and 5 again. And then this 4 can be broken down to radical 2 and radical 2. So hopefully maybe you've learned this previously. But every one of these, it's kind of, we call it a prime factorization because they're prime numbers and they're the factors of 2,500. But it's like a tree, right? Does that make sense? You guys heard of the word fractal tree, right? Well, these are kind of the end leaves or branches of that factor tree. Once they're all prime, you stop. Okay? And now I'm just going to rewrite this as radical 5 times radical 5 times radical 5 times radical 5 times radical 2 times radical 2. Okay? Just rewriting all of these things, making sure I get every one of those prime numbers listed. Now, just real quick, think about this. If I take 5 times 5 times 5 times 5 times 2 times 2, I get that 2,500. Does that make sense? So I break it down to its prime. We call it the prime factorization. And now we're looking for groups of 2. The reason we look for groups of 2 is because if I group those together, when I multiply those together, I get square root of 25. Well, what's the square root of 25? 5. If I multiply those two together, what's the square root of 25 again? 5. Multiply those two together, what's the square root of 4? 2. Now I get 5 times 5 times 2, and there's no square roots here now, right? So they're all integer values, and it gives me 50 as a solution. Okay? So that's kind of the way you would maybe do that without a calculator. There are other ways, other techniques, but they all break down to basically that logic there to get to that 50. So if you look at, I'm just going to go back real quick to that question. I'm just going to try to regenerate a couple more. Someone gave me 52, 10, 25, 50. So it looks like they're all going to give you a perfect square underneath that radical if you do the subtraction correctly. Is that doable? And like right now, like I'm not forcing you to do this by hand. It is a good idea to learn that and revisit that. But at the moment, the questions that we're going to see, if you want to type them in your calculator, go ahead and do that. A lot of the other ones, like this one, that tells me that number underneath was not a perfect square, right? It's probably 17 or 18 or something around those two values. Okay. Does that answer your questions? That question? So I can't say it a little bit louder. Yes, yes. So if I've got, let's do, like maybe for some reason we do a square root and we get like 128 underneath there. Okay, 128 is not a perfect square, right? Okay, so I start breaking this down. I go radical 2 and 64. 64. We could really eventually stop there, but we'll keep going. Radical 2 and 32. Radical 2 and 16. Radical 2 and 8. Radical 2 and 4. And then radical 2 and radical 2, right? So I'm just going to, instead of rewriting it all together, what I usually do just to save a little bit of time is I just draw circles around them. There's a group of 2. There's a group of 2. There's a group of 2. So what we're seeing here is that this group is going to give me radical 4, which is just 2. This group will give me radical 4, which is just 2. Same thing here. But this one, like you said, doesn't have a pair, so it just stays by itself as radical 2. So now I have 2 times 2 times 2, which is 8. So 8 radical 2 is what we're looking at. And here's a way to check to whether I've simplified it correctly. Start with this number on my calculator, square root of 128. And I put it into a decimal format, right? I should be able to take 8 radical 2, put that into a similar decimal format, and if those decimal formats are the same, it tells me that that 8 radical 2 is still equivalent to radical 128. So yes, good observation there. You guys want to talk about any other problems on there? They're all kind of the same, right? Okay, just providing you maybe different ways of, instead of giving you explicitly the points here, now you have to pull the ordered pairs out of the graph. Okay, so it's really the same question. Vertical angle question. Okay, so some stuff that was from previous days. Hopefully we did well with those. You guys want to talk about anything specific, anything that has caused you problems throughout the week?